The most asked question in Unit 8 AP Chemistry exams is how do you identify the conjugate acid-base pairs? This is a complete 10-page guide to do this very easily. Don't forget that you can go to www.apchemistryrescue.com and find more files like this or download as PDF. The next page tells us that in order to find the conjugate acid-base pairs, try to find what is the meaning of Bronsted Lowry acids and bases. We know that it consists of two species that differ only by H plus a proton, an acid and a conjugate base. So an acid is an HA. This is any anion connected to a hydrogen ion. And once it loses its proton or the hydrogen ion, it becomes a conjugate base. The name is conjugate base, while it's actually the acid that lost a proton. Remember, there are always two reactants and two products. The two reactants are the acid and the base, and the two products are the conjugate base and conjugate acid. I'm going to repeat this because this is what you need in this video. The two reactants are the acids and bases. Conjugate acids and conjugate base are the products only. One more time. Acid and base are only in reactants. Conjugates are only in products. So when acid donates a proton, it becomes its conjugate base. When a base accepts proton, it becomes a conjugate acid. Example, HCl and Cl minus. HCl is an acid that contains a proton, a hydrogen. It loses its proton. When I say proton, I mean hydrogen ion. I mean literally just a proton. It's only H. It's only H. Proton does not have any electrons or neutrons in it. The hydrogen atom contains a proton and an electron. So once you loses an electron, it becomes H plus, just a proton. When you lose this one, the chlorine takes the electron from the hydrogen. So initially there is a covalent bond between the hydrogen and chlorine. In this covalent bond, there is a shared electron from each one. But once the breaking happens, the chlorine steals the electron because it has high electronegativity. It becomes Cl minus. It is minus because now it has one more electron than it needs. And the H becomes plus, it becomes a proton because now it has one more proton than the electrons because it has no more electron at all. This pair HCl is the acid because it donates a proton from Cl minus. The product is the conjugate base because it can accept a proton to reform HCl. Why it is called a conjugate base? It's called a conjugate base because if we try to return and change it back, then in order to change back into HCl, it has to accept a proton. So Cl minus is called a conjugate base, means it is the base in the backward reaction. So we have two operations only. In order to find the conjugate base, start with the acid, remove one H plus, and you will form the conjugate base. The charge will decrease by 1 always. So if it is neutral compound, it will become -1. If it is +1, it will become 0. If it is +2, it will become -1. So remember, always it decreases by 1. HCl removes H plus, it becomes Cl minus. So you removed one H, it becomes Cl, and then you add one negative charge or you decrease the charge. From 0, -1 is -1. H2SO4 is 0 also. You remove one, so it decreases by 1, it becomes -1, and you remove one hydrogen. So always don't forget two things you have to do. Remove the hydrogen and decrease the charge by 1. So here it was 0 and 0, it became negative and negative. Here, why it's not coming negative? Because it's already +1. So +1 in mass -1 charge, so equal to 0. So here it was 0, it became -1, 0 become -1. Here +1 became 0. And this is 0 also, again it becomes -1. And every time you remove an H. So NH4 plus ammonium became NH3, H2O become OH minus. If I want to do the opposite, then start with the base, add one H plus. Here we removed one H plus, here I will add one H plus. So if it's NH3, you add one more proton, it becomes NH4, and increase the charge. So if the charge is 0, +1, it becomes +1. If it is minus, like in hydroxide ion, OH, it becomes -1 plus 1 is 0. So if it's 0, it becomes +1. If it is negative, it becomes neutral. We just add one proton and one OH. So again, if you start with a base, the step by step is to identify the base you start with, add 1H plus to the formula, increase the charge by +1. That's your conjugate acid. So NH3, OH minus, changes NH4, H2O, and then add one charge. So NH4 plus, and this was negative, it becomes 0. So the example 1 is ammonia, NH3, the charge is 0 neutral molecule. You add 1H, it becomes NH4 plus because the charge was 0 and become +1 is +1. So ammonium is the conjugate acid of NH3. Example 2, the hydroxide ion, OH minus plus H plus becomes H2O. The charge is -1, you add +1, it becomes 0. So water is the conjugate acid of OH minus. You start with an acid, identify the acid you start with, remove 1H plus from the formula, decrease the charge by -1. That's your conjugate base. So if you have HCl, you lose a proton and it becomes negative. So Cl minus is the conjugate base of HCl. Ammonium ion, it is already plus. If you remove one charge, it becomes neutral, and you move one H, it becomes NH3. So see you in the next video for more examples, and let's know together what's the meaning of the amphoteric compound, how it can lose and become a base, or gain and become an acid at the same time. So see you in the next video.